Hi, today we're going to talk about the law of sines. So this is any old triangle, and we're going to use the law of sines to figure out new pieces of information about it, like the angle measures or the side lengths, with the law of sines. So the law of sines states that the sine of angle A divided by the length of side A, and of course side A is always going to be located across the triangle from angle A, this is going to be equal to sine of B divided by length B, and that's going to be equal to sine of C divided by length C. So there we have that. And now, what types of triangles can we use this law of sines with? Well, the types of triangles that we can use this with are classified based on what information that we were given with to start. So if we are given an angle and then an adjacent side and then an adjacent angle, we can use this. And then if we have an angle and then an angle next door and then a side, we can also use that. And last but not least, if we're very careful, we can use this with angle, side triangles. Now, one must be very particular in how we refer to this triangle here, obviously. But there are some other considerations that you have to take into account with this, and that's because some of the triangles that are formed with an angle and then a side can be quite ambiguous at times. So what I mean by this is that you can have two solutions with angle side triangles, you can have one solution, or you can have absolutely no solution. So let's consider acute angles first with our angle side triangle. And let's say that we're given measure of angle A and then lengths A and B. So we basically have this structure here. We have A, B, and then we have another A somewhere around here. And now, if A is really, really short, in fact, it's shorter than H, and H is the shortest length from this point here to a point along this line here, in other words, it's going to form a right angle here, then we have no solution if this is shorter than our height here. Because this is going to be the shortest length that we can have, the height. So if A is less than the height, we have no solution. Let's try another one. So if we have this triangle here where we have A, B, and then we have A, where A is equal to H, then we're going to have a right triangle, and we're going to have one solution. And that's the right triangle. Now let's say that we have, this is where things get kind of weird, if we have angle A, B, and then we have A going like that, and then we also could have A with the same length going like that. So we form basically two different triangles. We have one that's shaped kind of like that, and we have a really skinny one just like that. So if A is greater than H, but it's less than B, then we're going to have two solutions. And last but not least, if we have the triangle, angle A here, we have B, and then we have A, and A is really big, so big that it goes off the whiteboard. If A is greater than or equal to B, then we are going to have one solution again. Now let's talk about obtuse angles. So obtuse, we're going to have an A that's going to be really fat like this. And since A is obtuse, that means that side A has to be the longest side in the triangle. So if this is B and A is greater than B, then we're going to have one solution, because this is what it's supposed to be like. But if that's not true, we have, and we have A right here, we have B, then A is somehow shorter than B right here. A is shorter to or equal to B, and we're going to have no solution, because that doesn't make any sense, frankly. So let's try an example. So let's say that we have a triangle in which the measure of an angle A is 35 degrees, and then we have a side B which is 20 in length, and we have A which is 17 in length. So we have a triangle that kind of looks a bit like this. Or at least, we don't really know, but we can at least say that here is A and this is 35 degrees. And we have a B, let's say that this is B right here, this is going to be 20. And then we have some A, and we really don't know where A is going, but we know that A is somewhere over here and it's going 17. And so, first we're going to figure out what our height is. So, since A is less than B, we know that we're not going to have a triangle that's like this. So we know that we should start with finding our h value. And so we can use our simple sine function to do this. So we go sine of 35 degrees is going to equal opposite over hypotenuse. So it's going to equal our h divided by 20. So 20 sine 35 is going to equal h. And so h is going to equal about, using your calculator here, 20 sine of 35. That's going to be 11.472, rounded to 3 decimal places there. So we know that 17, so A is going to be greater than H, and it's going to be less than B, so that means that we're going to have two cases that we need to worry about with this ASS triangle, which, by the way, this is the only context where you should be able to write ASS on any test, especially a math test. And so we're going to split it up into our two cases. So let's consider our first case. So we have a triangle here. We have our A, just like we have up here. We have our B, which is 20, and by the way, this is 35 degrees. And then we're going to have an A going outward like this, such that our B is going to be an acute angle. So we're going to use the law of sines with that in mind. So sine of angle A divided by A is going to equal sine of B divided by B. So let's plug in. So sine of A is going to be sine of 35, and that's going to be divided by 17, and that's going to equal sine of B, which we have no idea what that is, divided by 20. So let's do some calculator magic after we rearrange this. So 20 sine of 35 divided by 17. Make this a little bit neater. And then we're going to take the inverse sine of that, and that's going to give us B. So just isolating the variable there. And so we're going to take our calculator, and we're going to go inverse sine of 20 sine 35 divided by 17. And so we get, for that value, we're going to get 42 degrees. So measure of angle B is going to be about 42.438 degrees. So to solve a triangle, we need 6 different pieces of information. 3 sides and 3 angles. So we have 1, 2, 3, and then we have 4 here. So we need to find angle C and side C. So how we're going to do that is first for C, that's pretty easy. Measure of angle C is going to equal 180 minus 35 minus 42.438. And we know this because we know that all the angles in a triangle are going to add up. If you add all those together, you're going to get 180 degrees. So if we do that on the calculator again, 180 minus 35 minus 42.438, blah, 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 we're going to get that measure of angle C is about 102.562 degrees. So now that we have that, we can use our law of sines to figure out C. So we're going to go sine of 35 divided by 17. You guys see this? Probably not. Okay, so divided by 17 is equal to the sine of C, which quite frankly I don't want to write out. I just have that stored in my calculator, divided by C, the side length. So if we rearrange this a little bit, we're going to get C equals 17 sine C divided by sine 35. So let's type this into our calculator, and we're going to get, let's see, 17 sine of that 102 number, and we're going to divide that by sine of 35, and we get C, kind of messy, equals 28.929. So now that we have our 6 very important pieces of information, we have officially solved this triangle. So let's consider our second option though, and that's that B is obtuse, meaning that, not meaning that it's stupid, but that it is greater than 90 degrees, like that. So this is going to be our A, and that's going to be 17. And so this is 35 degrees. And to figure this out, we can also use the law of sines, but we have to keep in mind that our calculator is going to give us the small acute B as a default. So if we want to find the obtuse B, all we have to do is take our acute B, which is right here, and go 180 minus that acute B. And that works because if we look at the unit circle, it's giving us basically this value, and the sine of this angle is equal to the sine of this angle. And if we want this angle, all we're going to do is take 180 minus this angle. So that's why that works. And we don't have this problem with cosine, so that's why I like the law of cosines a bit better than this, quite frankly. But so basically we're going to take measure of angle B, and that's going to be our old angle. That's going to be 180 minus our old angle, so 42.438. And that's going to give us our new angle, and so measure of angle B is going to equal, let's take your calculator, 180 minus 42.438. That's going to be 137.562 degrees. So now we have 4 pieces of information on this triangle, so that's good. So we have, let's see, we have that, we have that, we have that, we have that. All we need is this right here, angle C, and side C. So we're going to find C, angle C, very similarly to how we found it over here, and that's we take measure of angle C is equal to 180 minus 137.562 minus 35, and that's going to get us measure of angle C equals 180 minus that B value we calculated earlier, minus 35. Oh, very small, 7.438 degrees. So now we have 5 pieces of information. And so now we're going to go sine of A, and A is going to be 35. I should write that down. Sine 35 divided by the side length of A is equal to the sine of C, what we have right here, divided by C. So let's rearrange this a little bit. We have C is equal to 17 sine C divided by sine 35. So 17 sine of C, and C is going to be that 7.438. And then we're going to divide that by sine of 35. We're going to get C equals 3.837, which makes sense because C is a very small angle, so it's going to be a very small side. So there's our 6th piece of information. So we have officially solved both of these triangles, and those are the 2 cases that we can have with this very messy, very complicated ASS triangle. But that's it. Thanks for watching.